All right. So talking about UTF-8 validation, um, a certain interview question that that's one of the things we have to treat. I think before you attempt any of these questions, uh, whether it's mathematical or arithmetic or whatever, you need to know how the thing works in real life, and then it helps you uh, attempt the question very well. So, what is UTF-8? You know, it's a kind of encoding, right? Like, let's make a little reference back to American standard for code. Uh, what is it? Is it code? Code information interchange. I'm not sure. I'm not sure I'm correct. But this standard brought a system where characters, I mean, some number of some bytes was assigned to characters, right? So where um, we can have, let's say, 7 bits representing a character, you know. So we have from let's say 00001 to as much as it could take, and then we even had the extended uh, ASCII or ASCII. I think ASCII is fine. ASCII value that now made it 8 bytes, where we had the 8 one here. Okay, and then this the a good knowledge of how to convert from decimal to binary, and from binary back to decimal will help you know the value for um, each each byte. I mean, this whole thing. Okay, let's take a little rewind. 8 bits equals 1 byte, right? It's 1 bit. 8 bits equals 1 byte, and the 1 byte represents a character. Remember, C programming teaches us that uh, a character, the size of a character is 1 byte, right? So this now, if you check the do I have ASCII table here? Dun, dun, dun. Let me do this. Mm-hmm. Yeah, I'm gonna pick anyone at random here. I believe we have good information. Alright, so here we go. The ASCII, you see that the guy with this set of bits have something it represents, which is start of heading, you know, start of test, and then it continues. It continues until you get to oh, any any question, any confusion?
No, 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 no.
Okay. So when you get to 49, you start saying the things that you're very familiar with. Okay, even before 49, that 49 is 0. 48 rather is 0. You know, and this one is 1. So you see things that each of these bytes represents. So 1, 2, 3, 4, 5. They have decimal equivalent and then binary equivalent. That's quite interesting, right? So now this system try to map out, try to make each characters. I think it favored the English speaking um, nation. Yes, because we now had all the characters in our alphabet Yeah, and we had more. We had more. But this, you can see there is no, so far I've not seen any French or any Chinese. Okay, and I've not seen any Chinese character here so far. So how do we now? I mean, it was looking okay because um, every country could have their own documents. I mean, you could have your own, you could do your own thing. But then with the World Wide Web, there is need for us to be able to send documents or information from here to another country. So what system? Where does that start? Then the need for a standard arose, a standard that can encode these things. This incompatible system of codes, this incompatible encodings. So what will not bring them together? What will not bring them together? Now let's go back and learn more about these guys. Now this guy, you've seen that it represents um, this is the binary equivalent. The decimal equivalent is 1. As hexadecimal equivalent. It's important to pay attention to the hexadecimal because yeah, it makes you understand the the UTF encoding. I mean, I don't think you can do without it. You want to do without it. So this is no character, no byte. This is the start of heading. Now let's, before we get to that point, let's look for a quick way to convert this guy to byte to decimal. Now you may have come across this before, where we give these guys indices. So this is 1, this is 2,
It's
this is 1
zero now.
because usually when you're converting to decimal, you will give this guy an index of um, okay, we are working with 2, right? So this will be 2 raised to power 0.
Zero.
So it has index of 0, index of 1, index of 2, that way. So you have 2 raised to power 0 be 1, anything raised to power 0 is 1. 2 raised to power 1 will be 2, anything raised to the power of 1 will be that
Okay,
same number.
yes, yes, yes.
So it keeps increasing.
Four.
So 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, that's what we'll have here as 4, and then we'll have here as 8. Um, right where, and then we'll have here as what now? That should be 16, right?
It's 16. Yes.
Mm-hmm. Now writing is it's not easy. Manage my writing like that. 16, and we'll have here as 32,
32.
and we'll have here as 64. I think I need to type this out.
64.
It's not favoring me again
48.
writing it out. So let me just type it. Tiny letters. I think this will be better. So I need to wipe this off. Is someone feeling sleepy?
No, I don't worry. By the midnight. You know,
Okay, so let me start from. So this is 2, 4, 6. Okay, let's do it like this. 1, 2, 4, 8, 16, 32, 64, 128, I believe.
yes.
Let's now space them and have them sit on top of the particular bit at they represent the equivalent. So we have it as this. How do I format this to look beautifully well? Tan tan tan. Alright, so I think I want to keep a space between these zeros. See if they will take the particular position. Okay. So I like to make a significant demarcation between the half a bit, so I think this is cool. So you go this way. I wish I had a pen to make this writing easy. I'll get one soon. Okay, so this guy now will save us from going to calculate that just time we divide by 2 and we taking and take all the remainder. This guy will save us from that stress. You know why? Because this is how we do it here. We know what do we want to convert. What are we to convert this guy is easy. You can't calculate the bit that has ones. So here we know that this thing is 1 because this is on. Remember, this thing is on off. These are switches on off. So this switch is on. Other switches are not on. Because this switch is on, it is 1. If we had it like this, let me so that you're following. What do you think it would be if we had it like this? Okay, let me even start for something simple. If we had it like this, we are all zeros. 0 0 0. What do you think would be the number? What do you think would be the number? What? What do you say? 3? Did you say 3?
Are you adding it with if you are only adding the one up and down?
Only up.
It's 1.
No. This is it. If you had it like this, it would be 128. Let me give you another example. If you had it, you 128. If you had it like this, 0 1. No 0.
Okay,
0.
that was you mean.
You got it right?
Yeah, I'm trying to get it.
1.
So as the switch is on, you not count it.
This will be 10. Let me illustrate that now. Usually we want to convert a number like this to base. Come on, right where? This guy said I'm not right where today. Give me a straight line now. So if you want to convert this number 10 to base to binary, let's see. We're going to convert 10 to binary and try to convert binary back to 10 and compare with our answers here, and then I'll tell you, I'll try to explain again what is happening there. So first you divide by 2, right? And so dividing by 2, we're going to have 5 here. Right? So, and it will be remainder 0. So 5 R 0. And then we are going to divide by 2 again. Since you are converting from base 10 to base 2, is 2 that will divide. And here, of course, you're taking the integer value. We are going to have 2, remainder 1.
Remainder 3.
Which is 2 remainder 3 again.
Remainder 1.
So this is going to successfully divide 4. So we're going to have 2 remainder 1. And so if we come here again and divide this by 2, we are going to have 1 now, remainder 0. Right, now what is the problem? Remainder 0. Okay, and so we'll have here, we are going to have 1 divided by 2 as well. And of course, it will get nothing, 0. At least C programming should help you understand this better. Remainder 1. And then usually, you take your answers from down to up, right? Down to up. So let me get another color and indicate that we're taking these answers from down to up. So let's draw this arrow here like this. Okay. Now, if we take your answers from down to up, our answer will be 1 0 1 0. Yeah, I think I need to type this one. Why is this guy misbehaving now? Why is it not as though the ink is finished? Yay! Okay, so it now become
Mouse.
1 0 1 0. Is it from a mouse?
Yes, it's your mouse.
Oh, this is where the mouse is moving well. I is not writing well. So since here is 1010, you can feed the other 4 bits with zeros. You can see. So this is 10 in binary.
Okay. Yes, it's 10. True, it's 10.
This is 10 in binary. Now the zeros you put by the left hand side are insignificant, but when it's by the right hand side, they are very significant because they
The
will
ones
push the
in
ones.
between.
So that's why you can add it's just like putting 0003 zero by the left. They are usually insignificant, and so it is in this case. So this is
Mm.
10 is this in base. So let's now convert this back to base 10 here. Now usually the way we do it is we'll come here and index it. If you remember, we'll index it where this one will be 1, this one will be 2, 3, 4, 5, and let me just do that and not just talk. We'll come here because I'm understanding how these things work. If you don't understand how they work in real life, programming it will not become a problem. So we'll index it from 0, 0, 1, and this will be
You've done
2.
it already now.
What?
Should it, it's the same one that you did in that
No, it's
10
different.
No,
above
no,
it.
no,
It's
no.
different.
He has not done it. That one is for 1.
He says for what?
You see what I'm saying now? The one under 128.
That's for 10 now. He has not really. See, we are converting back to
To
10.
decimal.
Want to convert from binary to 10.
Want to convert from binary now to see what it is in decimal. Whether we'll get 10. You understand? Are you following,
Oh,
sir?
oh, 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 oh. I just got the method that you were trying to explain before.
Ah,
That was why. Yeah, I just saw it now.
you saw it now. So tell me about it. Tell me about it. What did you see?
Yes.
You can't laugh with that one. Wait till you see the
See, na sleepy laugh.
It's okay. We'll come back. We'll come back to that. We'll come back to that. Now, since this thing is like this, we want to convert to 10. We can as well throw all these things off because at the end of the day, they will give us 0. They will give us 0. So long as it's not significant, it will be still be 0. But let's just put it to make for this illustration. So the first thing you want to do is, first of all, this guy is in base 2. So the base you always have to remember that it's in base 2 because you're going to use that 2, right? This 0 to what are indices. This one now is the base. So if I come here and now say the first thing I want to do is whatever the indices is, we multiply 2. Am I correct? Yes. So it will be 0. We have 0 here, the first 0 times 2 raised to power 7.
Yeah. A 7 will be now.
Now why?
A 7.
Plus 0.
Don't copy and paste now.
Okay. Let's do it like this. Okay, so paste 0 to 6.
6.
So plus this raised to power 5 and plus this raised to power 4, and then the first significant number is what you're getting now, so it's gonna be 1. So let me just place this to the 1 raised to power
Where the 3 day?
what?
Yes.
Okay.
And then we have
0.
0 to power 2, and then we have 1 again and 0
1.
again. So let me enter and do plus here. Plus 1 raised to power. So 1 times 2 raised to power 2, and then
So I'll be
plus
1.
is it 1? Oh, 1
Is it one?
is 1.
Okay, it's one.
And then we now have 0 times what raised to power 0. All right. Now let's make progress with this. Now this will go ahead to give us something like this. where we have it should not be equal to. I wish there was more space in this board on this board. So this 2 raised to power 7 will be, this is gonna suffer. 2 times 2 times 2 times. What's 2 raised to power 7, please? I find out.
That's 128.
Are you sure?
Yes, that should be it.
2 times 7 times 7 now waiting. I mean 2
Wow,
times 2.
my brother. Are you sure it's 7 times 7 that will help us?
No, 7 times 7 cannot help now. Let me use my command prompt.
Okay. Okay. Let's
2
figure
times
it out.
7 now 149 now.
149.
149. Yeah, there you go. Get it this way.
Alright, let's take it from here. 2 raised to power 1 is 2. 2 raised to power 2 is 4. 2 raised to power 3 is what? Mr. White?
2 raised to the power of 3.
Yes.
2 times 2 times 2.
Which is?
2 times 2 now 4 now 4 times 2 now 8.
Okay. I want to verify your answer here. It's okay.
I want to know if you go to school.
So just so it's supposed to have 2 times 2, 3, 4, 5, 6, 7. So add the
It's 128.
No, I said 128. So why would I call
I
it?
said 128 first.
and we'll find out. So 2 times 2 raised to power 2 is, let's take it bit by bit.
Use your
2 raised to
your
power
share
1
now.
is 2 raised to power 0 is 1. 2 raised to power 2 is this. So at the end of the day, you discover now you're seeing where we got this thing from. That's what I want you to appreciate. Right? So 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8, raised to power 4 is 16, raised to power 5 is 32, to power 6, right? Am I correct? Hope I know what I'm taking. Hope I'm correct. And then
64 and 128.
we have 1, 2, 3, 4, 5, 6, 7, 8. So 2 raised to power, okay. So 2 raised to power 6 is 32, 2 raised to power 7 is 64. That's what I was looking at. 128. So it means in this place now you're going to have 0 times 128. And here we're going to have 0 times 64. Here is going to be 0 times 32. Here is going to be 0 times 16. And here is going to be 0 times 8. And 0 times 4. And 0 times 2. And 0 times 1, because anything raised to the power of 0 is 1. So if we put all these things together, it will be equal to, because 0 times 128 is 0, so it will be 0 plus, here is 0, and here we have 0, it will be 0. You can see that, you can see the essence of that insignificance, how you can safely ignore them while performing this arithmetics. So 1 times 8 is 8, it's not, plus 0 here, 0, and then 1 times 2 is 2, plus 0. All of this will still be equal to 10. Is it too magical?
Who bring about this idea of doing this long division? What are they trying to achieve?
What? They want you to cry. They want people to cry. They just want to see
brother.
one day shed tears.
But like,
Eh?
why a person they wicked enough to do this kind of thing?
This guy.
It's God I know how many wickedness they've done
So-
to us.
So, okay, so this was how we learned it in the primary school in those days.
Yes, man.
And then, but I came and said that, wow, I can just look at this thing. Just remember, just to put this guy here, I can just look at this guy. So since this guy is 1, I will take 128. I say it's equal to 128. Since this guy is, I'll just go for where the 1 is. All 1 is just here. That means all these bits are off. Only this one is on. I'll go. The position is 1. I take it. No, here now, all these things are off. Only these two are on. So this one is on, is 8. This one is on, is 2. 8 plus 2, 10. So I don't need to go through that long route that we just went through now. So if I'm sure if I add one more byte. Now remember the 8-bit percent 1 byte. If I add one more byte, you'll be able to tell me exactly what number it is. And if you take it through this rigorous process that we went through now, this arithmetic process that we went through, you will still get the same answer exactly. Converting to base 2 and back to base 10. So let's try that. Let's do this. So you tell me what is the decimal. Tell me the decimal equivalent of this byte right now. Without disturbing your head. I'm waiting.
20.
Great. So you're making progress. 20. So with this now let's talk about.
I don't agree.
You don't agree?
I don't agree.
Alright,
That is
I
crap.
don't agree.
talk to me now.
It's 20. It's 20. I don't
Okay, you
agree.
don't agree.
It's
It's
20.
20. Okay, his own is 20. Your own is 20. Okay. At least your voice was hard. Now, if you oh, what was I trying to say? That's Joshua. Now you need to understand how hexadecimal works, right? Why is this guy in decimal? What is it about it that makes us regard it as decimal? Now, observe that decimal, we're dealing with 10. Decimal are numbers in base 10. And every number in a particular base cannot contain a digit that is bigger than the base. If it's in base 8, this number now, for example, can be in base 8. So no single digit will be up to 8. Right? And so when we say that base 8 is octadecimal, right? Octa.
Mm-hmm.
So no number will be up to 8. So this is what octa looks like. If you have octa now, let's take it from the smallest number to the bigger number. Octa will look like this, where we have 0, we have 1, we have 2, 3, 4, 5, 6, 7. Once it gets to 7, you can't continue. You start having is it 10? Yeah, 10. Yeah.
Yes.
11, 12, 13, 14, 15,
To
17,
jump again.
20. Right? So 8 will not even appear anywhere. Now let's display what happens in decimal. Similar things. In decimal, it is quite obvious, right? Let me start to make these guys align. Same line. So in decimal has some long range where we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Now, we just covered all these guys, and then that's it. But for hexadecimal now, you cannot have let me demonstrate what I mean there. X. Yeah. So for hex now, you want to continue, right? It covers more than this guy. Hex is base 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this guy cannot begin. You understand that? Okay, excuse me. Let me make this one as long as the other one. 10, 11, 12, 13, 14, 15, 16. Now the base 10 itself is not regarding this 10 as 10. No. It's regarding this 10 as the starting of another sequence, just like this one, the octadecimal started here again. So here it was 0, so 1 0 1 1 1 2, he gets here 2 0 2 1 2 2 and continues. So this one is 0 1 and gets here 1 0 1 1 1 2 until it gets to the end 2 0 that way. So it's not like this guy is really the guy that represents
not 10. Yes.
So
not the 10. It's more like a back guy. Telling you that we are starting a new count.
Great. So here now to we need to continue because this guy is in base um, um,
16.
base 16. So we cannot come and put 10 here. 10 means 10. Let me just call it 10. 10 means we are starting a new count, like he said. So that's why did I use alphabets? A, B, C, D, E, F. And if you calculate this, this is 9, 10, 11, 12, 13, 14, 15. So they couldn't add G. G will be 16. G will mean 16. So it gets to F, and then you now have your own 10, 10, which is the beginning of a new count, like our brother said. So 11, 12, 13, 14, that way it continues. It gets to 15, it gets to 19, it becomes 1A, 1B, 1C. I think I should make it longer because of this decimals. Let's get to the interesting part where we use the, here we have 1A. So 15. Let's
Can
go
you just do
1, 5.
dot, then 1A, 1B, 1C.
Oh, man, smart. So you're smart. You're a smart young man. So dot dot dot. We now have let me have 1 9, 1A, 1B, 1C, 1D, 1E, right, and 1F. Let me start at 1D. So that's it. So you need to understand these guys, right? Now let's go back to this guy. So 10 has, this will be A, and 20 will be what I don't know. I like to write a C program that converts decimals to what now? The hexadecimals. Okay. Now, what next? Haven't known the easy way to convert from binary to decimal, decimal to binary, and knowing what this significant number basis in programming entails, what they can carry, what they can contain. And now let's talk about UTF-8 encoding. We've understood now that 8 bits represents, every 8 bits represents a particular character. So it was an encoding system, and UTF-8 that came to unify both the one that Japanese have, the one that China's have, the one have that. So there's something called Unicode, right? I browsed, I opened it on Google a while ago. Where's that guy? So this is list of Unicode. Unicode now, it is should I say it's not really an ASCII thing or say UTF. Oh, one man called it a miracle. This guy came and became a unifying factor, such a way that it does not it does not make for, it takes care of unnecessary waste of memory. But let's save ourselves from the grammar. We came to learn how to encode. So this is the Unicode U plus. This is how it is represented. This is the code point. So U plus 0000, U plus 0001. With this thing now, we can have more characters. So even emojis have their own codes. Here, their own Unicodes. So let's now try to encode this in what now? Watch this. 0002E. So this guy is in hexadecimals. So they say ASCII punctuations and symbols. That means that C recognizing ASCII in a way. ASCII digits. ASCII punctuations and symbols again. Latin alphabet uppercase. You can see Latin alphabets have their own Unicode. And of course, this one was covered by ASCII punctuation and symbols, ASCII. Now let's go beyond Latin and get to the place where we start seeing things that are not Latin now, that the one that ASCII values could not cover. Hey my friend, okay, these things, you can see even things I don't know. European Latin, oh yeah, deprecated. European Latin, let's keep going down. You have started seeing characters that African cliques, interesting. Please, let's start from simple ones. We'll come back here. Let's start for the ones that are ASCII friendly. Okay. Let's say we wanted to encode, let's take an alphabet. Let's say lowercase a. No, let me take something that has decimal in it. Yes, that has a hexadecimal in it. Rather. So let's take this one, u plus 004a. Now these guys are now representing 4 bytes. They are representing 4 bytes. 0, 0, 4, and a. So what will it look like? Let me copy this guy. Let's try to encode it in UTF-8. All right. I'm going to paste this here and try to represent it in the bytes. Represent the bytes. Okay. So A is 10. You remember. So we're going to have these bytes like this. We'll have 0000000 here for this one, 0000000 for this one. This is 4, so we have 0000001. No, 0100. I hope I'm correct. You remember, right? 0000
1248. Yes, 124. So then for A is 10. 10 should be 1010. Yes.
Yes.
8 here plus 2 here.
Yes.
You see how you're converting. You see how converting number bases without calculating anything. You're just doing addition. Just remembering what is up here and doing addition. See how easy life can get. So this is it now. So this is 004A. It means these guys are as good as insignificant. This 00, there's no point. Let's just stop wasting space. Right? Now
Put down there for reference.
For reference. Say okay. Reality bit here for reference. So, and this comma I put is not needed. I just wanted to put demarcation between them. Alright. This is 4 bytes. And this Unicode is saying that yes, this is how it is looks like. Now let's try to encode this. How do we encode this in UTF-8? Now note this about UTF-8. When a character has 1 byte, it begins with 0. In UTF-8, it begins with 0. So once it begins with 0, it's a 1 byte character. So we are expecting other characters 1, 2, let's say 1, 2, 3, 4, 5, 6, 7. So you're expecting 7 other characters. So just know that okay, this is a single byte. In UTF-8, this is treated as a single byte. Okay. When it begins with is it 10? No, 10 is continuation. So let's say 110. This is for 2 bytes. So it will now expect 5 other characters. You're making progress. In the beginning is 1110. This is for 3 bytes. It will expect 4 other characters. When it begins with 11110, it is expecting 3 other bytes. Now let's talk about this unique one. I'm going to separate it. When it begins with 10, it is expecting 6 more bytes. But the thing about this guy is that it's supposed to be continuation. What we call continuation byte. Okay, continuation byte. Why this one is supposed to be like let me label them all. This guy is when it's 1 byte. So this solves the problem of a machine seeing 8 bits and interpreting it as the end of the string, because it was designed to interpret to it as a to recognize 8 bits, 8 bits. Well, that's not my business. Let's pick the English that we understand. Let's forget about plenty of histories. We want to be able to encode this guy in UTF-8. That's all. And then be able to write a program that will do something that can perform a certain operation that any operation we think of. You know. Um, okay. So what do I mean by continuation byte? When the byte is 1 byte, we expect 0 to be the first. When it's not 1 byte, or it's more than 2 bytes, we expect this to be the first and the second byte to begin with 10. This is very important if you will understand this task and do it well. Then it's very important to know that. So you at somewhere in your code you place a check to see that, hey, check whether the second byte begins with 10. You work with bitwise operators, right? Okay. And then when it begins with 1110, we expect 3 bytes. We expect 3 sets of these numbers. And those set of numbers, the other two must begin with this, otherwise it's invalid. Must begin with 10. And same thing for this one. We expect 3 more bytes when the first one begins with this. And the other byte must begin with 10.
Yeah.
So let's try to interpret this code now. Now we are going for the significant ones. We are going for the significant ones. Let's see. So we are going for, when we say significant, we are targeting the last point where we have 1. So let me encode this right now in UTF-8. So I'm going to duplicate this and say UTF-8 equals, right? Or let me even say, so it is UTF-8 of this code. So let me make it clearer. Say U plus, this is Unicode, right? Unicode point 004A in UTF-8 is this. Okay. Equals, we are going to end up providing another bit. I like to take it from right to left, okay? So I'm going to start bringing this bit in. So 0, 1, no, am I correct? Okay, is it now 0, 1, 0, 1 from right to left, and then 0, 0. So we would have seen that we've not gotten to where the significant number stops, and we already have 6 bytes here. Since we already do, then we'll treat this guy as a continuation byte. We will stop taking from here and add this 10 that has to be here. I take that again. Since this guy has not gotten to this place, we've seen that 1 byte cannot contain this guy, so we cannot treat it as 1 byte. We have to treat it as more than 1 byte. Obviously it will be 2 bytes, so we have to stop at 6 bytes and put this 10, indicating that it's a continuation byte. So 0, 1, right? And then this is a byte of its own, to go away. Now let's continue. We'll not continue from where we stopped here. We stopped at 0, 1, 0, 1, 0, 0. We'll now continue. 0, we take this 0 here. 0, we take this 0 here. 0, we take this 0, 0, and we'll take this 1. We've taken all the significant values now. So let's see. 1, 2, 3, 4, 5. So since it's 1, 2, 3, 4, 5, that means you can take 3 more characters. And this is the guy that begins the characters that has to do with 2 bytes. And it's 3 number, 1, 1, 0. So you put it there. 0, 1, 1. It's complete. This way we've translated this guy to UTF-8 like this. But this is not the end. You have to give each hexadecimal value. But let's begin by getting each decimal value first. So, any confusion?
Um, just a little bit recap. After you
Okay.
did that 0, 1, 0, 1, then you now counted the 3 zeros. Now because the last 0 is supposed to be 1 byte, we now put 1 there. Then we now counted 2 two zeros. Before we have one, and that one is 2 bytes, but we no put. Okay, 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 okay. Abi?
Okay.
That place.
Okay. I wish I paid attention.
That
Very.
one is 2 bytes. Okay, that's why we put one.
Just know that I
No,
was the
so they
one.
collect from
I
the
was the
big
one that
gallons.
added this thing, right? I was the one that
Mm.
added this thing because
I don't
it's
carry
something that
gallon come
must be
inside
there to show
yesterday.
that okay, this byte didn't begin from here. It's a continuation. So this other one I picked them from here,
Yes.
010100,
Come inside me to come back and go.
right? Then I stopped here. I continue with this zero on this one zero, this zero here zero, this zero here zero, this zero here zero, and then this one here one. I then stopped and treated these ones as insignificant. They came to waste space, memory space. Do you understand? So
Mm.
I had up to this point, I have 5 bits here. I have 3 space left. I had to go and pick this guy. Why this guy? Why this set of characters? Is because they are the ones that when we see them, we expect 2 bytes.
Mm.
So they have to be there. So I added them here. So after adding them, I'm breaking the codes now into four into what is it nibbles? I think they're called nibbles. Hope I'm not mistaken. If I'm mistaken, correct me. Uh, ah, it doesn't sound like I'm correct, but it looks like it. Half byte, right? So I have to break them like this to okay. Let me go straight to their hexadecimal value. This will be 1101. This will be we have one here, two here, 4 and 8. So this is 8 plus 4, 12 plus 1, 13. So 13 is what in hexadecimal? 13, 10, 11, 12, 13. So A, B, C, D. 10, 11, 12, 13. A, B. Remember, this is 9, 10, 11, 12, 13. So this is D in hexadecimal. We'll come here now. Let me put it at the center. We'll come here now. This is 0, 0, 0. So we'll put 0. This is 0 in hexadecimal. Right? We'll come here. This is 1, 0, 0, 0, 0. So 1, what is here? 1, 2, 4, 8. So this is 8 in hexadecimal. Put an 8 here. We'll come here. Obviously, this is 10 because this is 8 plus 2. So this is A in hexadecimal. This way, the hexadecimal value in UTF-8 is equal to D08A. We just got it. So this guy with this code point, with this Unicode, is this guy in UTF-8. Any confusion? Any question? Is it entering? Yes, Mr. White. Did it disappear? Okay. Okay, you're making progress, right? Hey, I've slipped taking my members, my counterpart away from me. Hey, learning how to
Yeah,
do.
yeah.
Okay. Good, yeah, yeah. All right, so let's try to convert. It means we can convert from either way. We can encode, we can either decode or encode. We can take this back to the other way. We can take it from here to here. It's just the same logic. Therefore, if you're writing your program, you are checking to see does this guy have more bytes. You're checking to see the significant bytes. So it's like your program should work like when this guy is passed to you. When this guy is passed to you, like an array that has 0, 0, 4 and this. Once it's passed to you, your program should check the binary value of each of them to see um, how many significant bytes are there, and take from where we have significant bytes and see and start checking how many spaces, performing all these checks and checking to see whether the one that continues it has 1 0, and 1 0 will be the binary equivalent for what would that be? 2, right? 2. 0, 1. 1, 0 will be 2. Because here will be 1, there will be 2. You will take off all these things and check. That's by the way. I hope I'm not talking plenty of grammar. Now let's take one more example. What do you think? Or should you convert from here to here? By the way, let's see. Let's see how accurate we are. Let's use Google to check. Let's be sure. So I'm gonna ask Google what or should I ask? Let me ask ChatGPT. Yeah. Hello. What is the UTF-8 value for the Unicode? 0x code point is represented as the byte 0x for a. What is? Don't confuse me now. Give me the hex. J. What is 0x for a again now? This is octadecimal now. We do. I refuse to be confused. Where is x coming from? D08A says 0x. Maybe I'm not typing the command well. Yeah. Okay, let's find out. What is D08A? D08A. Let's know how correct or wrong that was. So I will give you a UTF-8 value for you to provide the Unicode code point. So
what did I miss?
We didn't miss too much, just that we're trying to validate our answers. Okay, this guy seems to be saying that I am wrong. This guy seems to be saying that I'm wrong. Saying that this is rather for this. Let's go. Let's check again. What did I do right? 101 1101 08 A. Okay, you know what? Let's take some task. From here, let's see what's happening. I want you to test my knowledge of UTF-8 encoding. Give me some characters and their Unicode code point for me to provide the UTF-8 hex value. Correct me if my answer is wrong, and should I say score me, comment me if the answer is correct. I want to see what I did wrong. That's making it now. I want to tell me, okay, it's wrong. Give me one at a time. Guys, let's do this. I'm trying to understand what I did wrong. What I may have done wrong. So it gives me this one. So this is the Unicode for letter A. So I'm going to find it now. Let's see. Sorry, I may not explain this time. I will just be doing it silently this time. 0041. 0041. Okay. So here we go. So 0041 will be. I'm going to ignore the zeros. Let's go. Wait. 4 will be 0. No, 0, 1, 0, 0. 1, 2, 4, 8. And then 1 will be 0, 0, 0, 1. Oh! Oh! Okay. I think I'm seeing something I did not do right. But let me do this one first. If it works, then I would take it as soon as it. So now this guy will be um, this guy will be the same thing now. The same thing. The same thing. This is 1 byte that begins with 0, so it will be the same 4 1. Let's try. I'm not scared of being wrong, Let's try again. Okay, so the hexadecimal value is 4 1. ChatGPT.
Hex number 41.
You provided the correct UTF hex value. Right, so let's continue. Euro sign. Guys, you're making progress. I will explain what I did wrong in the other one. I will explain. Let me do this one. Okay, so this one is this, and this means 2. 2 is 0010, and the mistake I was doing, I was completing them 8 bytes, putting plenty unnecessary zeros. I think that's the mistake I made. 0000, and 0 is 0000. So I'm supposed to be taking neighbors. A is 10, that's 1010.
1010.
C is, what's that? 10, 11, 12. So
1.
1 is it 8 and 4 now? 1100. So in UTF-8, taken from the left, I have 0, 1. No, don't stop me. 0, 0, 1, 1, and then I take this 0, and I take this 1, and then I put my 0, 1, and then I give this a space. Sorry, I will explain later. Let it work first. Let me be correct first. Then I put 0, 0, 0, and then I put 0, 1, 1. Somebody's following. So I break this into these bits. This will be C. This will be 2. This will be 10. A rather. This will be C again. Okay. Let's go on to C to AC. So GPT, Let's try. C2AC. Is that correct? Hey, be fast. What is that?
GPT-7 don't slow down for my PC.
Is it? So,
GPT slow for my PC.
all right. So that means it's working. Let me now go back to that one that didn't work well and correct some mistake. I shouldn't have been completing the whole byte like this, right? I should have just gone for, since we have 0, so this is enough for the 0, for the 2 0 0 0 0 0. So for 4 now is 0 1 0 0, and then for A is 1 0 1 0. Okay, so if I had done it like this, I would have ended up having a single byte here. So I will come here. What I will now have here is this. Let me take all of this off. Taking it from the right hand side, like I like to do. I have 0 1 0 1, and then I will have 0 0, and then because it's
01.
0 0, so 0 1 0 1 0 0. So this is 1. I don't want to have 1 and 0. Okay, I can have 1 and 0. So it's a single byte. It begins with 0. Remember, 1 byte begins with 0. So this is a single byte. So if I break it into 2 now, I'll get the hex value. And it will be, this will be 4, right? 4. And this will be A. Okay, that was what ChatGPT was telling us. ChatGPT gave us something like 0x. Let me put it down here. This is 4. And this is A. So ChatGPT gave us 0x 4A. So that's correct. That's correct. So 0x is just 0x looks like one decorator. All right. So we've learned this, right? I think we've gotten this. Who hasn't gotten it? I think you've gotten it. So we can, this way too, we can take from here to and decode it and take it back to SI. Let me ask ChatGPT to give us a task. Give me do the
Mark.
What? Are you talking to me?
Mark. Mark.
I hope ChatGPT understands this. Okay, so it's giving us 4 8. This one I want all of us to do it together. 4 8. So what is 4 8? What is the Unicode of 4 8? 4 and 8. Let's go. You don't refer to it as 48. It's 4 8. Okay. Let's work. 4 8. Now 4 8 will simply be 0 1 0 0 and 1 0 0 0, right? So knowing the rule that this is a continuation byte, I think for 8 will be 4 8. It's a single byte, so what's the point? For 8 to be 4 8. Single byte means is that thing.
It's actually a single byte.
It's a single byte. So what we just do is just to put that format, U plus 0048, because it has to be 4 digits. Has to be U plus. So this is it. Mm-hmm. 65. Give me something. Give me something more complex. Now, what is this? I don't find trouble. Oh. When I say it says EB2B. All right, let's do this together. This is fun. I asked for it. Let's do this together. So we are taking from UTF to the Unicode code point. So let me take this off and let's do this. And then after now, I think we want to start coding.
Once start coding, have you won't go sleep. You know they go work for money.
Okay. Sorry. Okay, let's just do this and then you can code another day. Yeah, I thought we would do the coding. Yeah, it's okay. My brother really has not us think like human beings. So, so E will be E is A B C D E 9 10 11 12 13. So is it
E is
13?
14.
E
14
is
have you
14.
13?
Thank you. E is 14. So
14.
14 will be 1 1 1 0. Is that 8 plus 4 12? 4 plus 2 14. 2 will be 0 0 1 0. We're doing this together. Let me hear all voices. Oh, hand on deck. And
Yes. B should be is 11.
11
So that's the 10101 now.
1 0 1 1.
Wait.
8.
B at index 11.
B is 11 now, is it not?
Yes, it's 11.
So this is 8 plus 2 plus 1. 8 plus 2 is 10 plus 1 11. So
Okay.
this one is A. A is this.
Then 10101010
And then 9 is 1 0 0 1. Yeah.
8 plus 1. Yeah, 9.
Yeah. So now that we have this thing like this, what we want to do now is to bring these ones together to discover, to find out what we added, what we are going to remove from it to make it Unicode. So I'll bring this together as 8. You can see that it's obvious that there's a continuation byte here. That must be 1 0. And then I bring this together to, you can see it's also obvious that a continuation byte that was added here. And I bring this one together. You can see it's obvious that it has 1110. Remember, on our board earlier, we stated that 1110 means it is beginning of a set of data that should be 3 bytes long. So it's there's conformity here, right? So 1110, that means you are taking off this 1110 first, and we're taking off this 0. So we'll copy these guys. We know that this was the guy we added uh, uh, to make this UTF valid. Okay, so I'm going to take this like this. I'm going to start forming a new one. And let's say, so our answer now is not equal to, I copied this, so I'll paste it here. I copied this 0010. Now this guy, we know that this guy is not among. This guy was added for to make it
To
UTF-8
complete
valid.
it, yes.
Great. So I'll take this guy
Yes.
as well and put it here. I'll put them together first. I'll break them later. And then the same thing happened here. So I'm taking the last 6 bits, take it from here, and then I'll add them here. And then now I'll start breaking them into neighbors to find out what it really is. So having done this, I can now comfortably state that the Unicode code point is U plus, this one is 2, and one is what?
So,
Right?
one, this is 248. That's 248 now, 14 now. That's E.
Okay. The other one is A.
Then 10 is A. Then 1 plus 9, yeah.
So let's go and see. So GPT, are we correct? You're close. Whoa. Oh my god. 2E.
So
It was quite different. What
2
happened?
B A 9.
Oh no 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 no. Unicode code. Wait, what is it saying now? I don't understand what it's saying. Oh, UTF hex code
Okay,
E2BAA.
that this particular A2BAA9 corresponds with 2EA9. Meanwhile,
Oh,
what we needed was the, yes, yes.
E2BAA9. What is it saying now? I don't understand what it's saying right now. Give me hex code. Let me give you the Unicode. And you're telling me that the hex code that you gave me
It's obvious
corresponds.
that we got it right.
Oh God, so why is he saying
We
why
got
is he
it
saying
right.
you're close but not quite? Is he getting something disturbing his head? Let me find out. Hey, was the UTF-8 hex value for the Unicode? Yes. Let's find out whether something is shaking the head of GPT. Take this thing down and show me what is happening here. So you're actually correct. Am I? Is it that EA? No, no, no. EABA9. We are not correct.
How are we not correct? Scroll up now. See the question they asked us.
Sorry, they gave us this
E2BAA9.
E2BAA9.
Oh,
So now
oh,
I'm saying is
E2BAA.
EABAA9. So how? What? Why did we go? Where did we go wrong? Dun, dun. Where did we go wrong? All right, let me leave us to go and rest for today. At least the concept has been gotten, and then you know how to
Okay,
go about it.
let's sort this first now.
Okay. So we are in this kind. You go wrong. E is 14, and 14 is 111. 8 plus 4, 12. 12 plus 2. Mm-hmm.
I just secret, okay. Then 2 is
2 is 10010. B is 11, which is 8
8
plus
plus
2.
2,
10 plus 1,
11.
11. This one is 8 plus 2. 8 plus 2 to give us A. This one is 8 plus 1. So why is it not B? It's not B. And then, so we have to ignore this byte. Ignore this and took 100101, and then we took something here. Took this 010111, and then we have this left. So we took this 0100, and this is 2. This is E. This is A. This is 9. How? What went wrong? What am I missing? What could I be missing?
Is E at uh, 14.
Hmm? A, B, C, D, E, F. F is 15. So E should be 14. Mm-hmm.
A A10, B11, C12, D13, E14.
Mm-hmm. Mm-hmm. Mm. Don't know.
Tell him to convert it to do the full conversion. Convert to, yeah, binary.
I did not learn this thing from you too. Are you sure you can? Okay, you can do all things. Um,
Yes, convert to binary.
Perform the coding of of
EABAA9. Abi?
no E2.
Okay, E2. To what it was.
Da 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 da. This guy is serious. Oh. Wow. ChatGPT is more wonderful than I thought. Byte 1 EA E0 AE. Ah ah. I refuse to be confused. What did you ask you to do? Perform the conversion of this step by step.
So this is how it converted it to binary representation first on line 4 to EA9 in binary.
Something else is happening
That's
here.
this is it. It's I think
This guy is arriving at the same answer with us. What is happening here now? It's not the same answer. What is happening? Is started be having headache. So what happened before? Alright, let's end. Even study P is feeling sleepy. Let's just end here. We'll code next time we meet. He first did this. Is this not what we first did? Let me compare this what we did. 2EA9. Is this not 2EA9 here? So what was it telling us we were wrong before?
step two, it's determine the number of bytes needed for encoding. So they said it falls in the range of 0800 to FFFF, which requires 3 bytes in UTF-8 encoding.
So it was not 3 bytes we use here, where we made one
Yes,
coordination
that's 3
byte.
bytes now. Yeah, that was the yes,
Add
yes.
the leading
Then add leading bits based on the number of bytes needed.
needed. He's doing it both ways. So he took it back to here and took it to this place again. So 1110 was not the one we removed before, and coordination by 10. This guy I don't understand. So what did he say we
It
were wrong
added the
before?
continuation byte again.
Hmm?
Instead of removing it, added it again. It will show you the full. Okay.
Leaving room for the coordination bit as needed. Okay, it's actually what it's actually doing now is I refuse to be confused. It took this guy from here. We ask you to perform the encoding of this step by step. it it this guy is supposed to be a UTF-8 something that's supposed to be to be converted to this. So he showed that the answer is this, and then started showing us how he got the answer. Uh, how he got the answer. But my question now is, how did he now landed in this kind of thing again? What is this? After giving us the answer, he now tried to start. He now started encoding again. What is he encoding here again? And this value is quite different from what we ask it to do. So at this point, ChatGPT is feeling sleepy. Let's go and sleep as well and rest our head. So thank you very much. Let's keep learning like this. Even the hardest things will become doable. Ah, time is fast spent actually. Let's go and rest. Maybe next time we'll code it and then do some more tedious things. Fight
All
the
right.
test. Any questions, please?
Nah, not for now. No.
All right.